Alright, this video is to review some graphing parent functions. So this is from a topic from chapter 2, and we're just going to review 3 of these parent functions. We're going to do parabolas, square roots, and absolute value. Okay? So parabolas are quadratic equations. The parent equation, or like the basic equation, is y equals x squared. And then we have this other format over here called graphing form, where we can kind of figure out the parabola has been shifted from the normal parabola of y equals x squared. So normally we have a parabola that goes through the origin and there's a curve up on both sides like this. So what's happening in this graphing form where there's this a, h, and k is it's been shifted or flipped around or stretched or everything like that. Okay? So in parabolas, hk is the vertex, which is that lowest point. If the parabola looks like this, the parabola might be flipped upside down. For example, it would look like this. The vertex would still be up here at the top. So it's the highest or the lowest point in the center of the graph. So the graph might be stretched, compressed, and flipped, found from the stretch factor A. Right? And it also might be it's shifted left or right if there's that hk factor. So here we're going to focus on graphing a parabola, maybe a quick way if we're given this graphing form. To graph a parabola, start by plotting the hk coordinate. We can then plot 2 other points to create a parabola that follows a certain pattern. From hk, we can go right 1 and up 1, because that's normally where it is. From our vertex, here if I pick some points and plug it into y equals x squared, if I pick a couple points and I plug them in, -1 times -1 is +1. 0 times 0 is 0. That's our vertex right here. And 1 times 1 is 1. So if I were to plot those points, I'm really moving from the vertex left 1 and up 1 to get this point. And from the vertex, I'm moving right 1 and up 1 to get this point. So that's why I'm saying let's go right 1 and up 1 from the vertex. And we'll go left 1 and up 1 from the vertex. And then we're just going to connect them into a U shape if it's a parabola. Okay? How we know it's a parabola from the equation is that it has a squared. So that's how we know it's going to be a U shape. If there's an A value, we're going to multiply the up number. Okay? So it's going to be stretched taller. So we might have to change, instead of just going right 1 and up 1, we might go right 1 and up 2 or 3 or something like that. Okay? So we're going to start by identifying the hk, and we're going to try to graph these and including 3 points in our graphs. So the hk, we're going to do the opposite of this number. In our equation, it's x minus h. So we're going to actually figure out what's the opposite of this -1 right here. Well, it's +1. So that means the graph has moved to the right 1. And this number we're going to keep the same. And this one moves it up and down. So I have an hk of 1, 4. Okay, so my vertex, instead of it being at 0, 0, which the original parabola was, it moved to the right 1 and up 4. Or right there. Okay, so we're shifting this parabola, but instead of shifting each individual point, we're just going to start with the new points, the new vertex. Okay? So there's our vertex, and we're going to go right 1 and up 1 from there, and from the vertex again, left 1 and up 1. And those are going to be our points for the parabola. And when you're connecting it, make sure you connect it into a curved shape. We're going to do absolute value, which is more of a sharp V shape, so make sure you're trying to make it into a curve so I can tell you know the difference between the two. Okay? So the normal parabola was right here. I'm just showing you so you can get a sense of what's happening. It moved to the right 1, and it moved up 4, and that's how we have that red parabola on mine. Okay? So the red one is the one we're graphing for this equation. Okay? Looking at number 2, find that hk. The opposite of this number, so that means it's going to be -4, or it moved to the left 4. And we'll keep this one the same, the second term the same, so we have -2. So really this graph moved to the left 4, and it moved down 2 from the original. So our vertex and all the other points would be shifted down 2 and to the left 4. So there's our new vertex. Instead of it being at 0, 0, now it's at -4, -2. And we're going to go over 1, up 1, each side from the vertex. getting those 3 points plotted. Okay. Take a look at one more here, then we'll jump to if there's a stretch. Looks like a number 3. So my HK, H is a number in the parentheses with the X. There's nothing in there. And it's going to stay as a 0, which means it did not move left or right at all. And then we have a -5, which means it moved down 5. So instead of our vertex being at 0, 0 like normal, we're down 5. 1, 2, 3, 4, 5. So we're going to be down here as our vertex. And everything else is the same, so we're going to go right 1 and up 1 from the vertex, left 1 and up 1 from the vertex. Right? All of our parabola points, all that happened is this graph moved down 5 from where they normally are. Okay? You should be doing number 4. I'm going to skip that one for now. Let's look at if there is a stretch happening at all. Okay, so we're going to find a stretch if there's a number in front of the parentheses and the stuff being squared. So that is our A, that is our stretch factor. So we're going to still find the HK first, the vertex first. So we're going to do the opposite of this one, -2, which means this parabola moved to the left 2 from a normal basic x squared, and a +1, so it went up 1. Okay, so we're going to start by plotting that point, -2, up 1. So there's our vertex. Now normally we would go right 1 and up 1 from the vertex, left 1, up 1. That's what we did in the other 3 problems. However, I have this stretch happening. So what we're going to have to do is, if that means our graph is getting taller, instead of shifting left or right, that kind of makes the vertical part of it, the stretchiness, how wide and narrow it is. So if we have a stretch factor, we are going to multiply this vertical shifting by that stretch. Okay? So instead of going right 1 and up 1, we're going right 1 and up 2. It's going to be twice as tall as it normally is. Same thing, we'll go left 1, instead of up 1, we'll go left 1 and up 2. So you can see it's kind of a skinnier parabola happening here. Okay? So we're going to multiply the vertical part of our little pattern by that stretch factor. Take a look at number 6 here. We're going to do the opposite of this, so -4, 8 is our vertex. 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7, 8. Okay. And again, our normal things from that vertex, we're going to go right 1, up 1, left 1, up 1. And we're getting that because that's what the regular x squared parabola follows that pattern. Okay? But this time we have a stretch. We have an A value of -3. So what that means is we're going to multiply this vertical part by -3, which really means we're changing our direction. Now it's going to go down in 3. Instead of up, it's going to go down 3 because it's a negative stretch, which means the graph is flipped upside down. So from our vertex, we're going to go right 1. Instead of up 1, we're going to go down 3. So it should be like an even skinnier parabola, but it's flipped down. Right, and we're going to try our best to make it kind of curved. Okay? We'll look at one more with parabolas, and then we'll move on to a different type of parent function. Number 7 here. Okay? Find that HK, -5 and -3. Remember, we're doing the opposite of this one, and this one's the same. Okay? This guy right here means it moved left and right. And this number on the end is the up and down movement. Okay, so our new vertex, it's moved left 5 and down 3. Okay. Again, our normal little pattern, we're going to go right 1, up 1, left 1, up 1. That's normally what we're going to do if there's no stretch. But we have this stretch of 1/2. So really I'm only going to go up 1/2 on both of them. So it's going to be hard to tell on mine. Hopefully you can be more accurate on your own paper. And we're going to go right 1, up 1/2. That's my best there. Left 1, up 1/2. So what should happen is it's a wider looking parabola. Okay, so if you have a fraction, something smaller than 1 in the front, it should be wider. If you have a bigger number, like a 2, a 3, a 4, it should get skinnier. Okay? So you go ahead and do number 8, and we're going to continue looking at absolute value. The parent equation is just y equals x squared. That's the most basic one, and it's very similar to a parabola. It's going to be like, if I were to pick some points, let's make a little table here. -1, 0, 1. Absolute value of negative 1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. So it's actually the same points, but what would happen if I were to do more of the points is it's going to just be a steady straight line outwards in both directions. Right? So it's not quite the same as a parabola. The points would be different if we were to plot more of them. But how you're going to graph it, I want you to make sure it's much sharper. It's much more like a V shape instead of a U shape. And our graphing form, if you notice, is basically the same thing as it was with the parabola, except there's an absolute value there. There's still the A in the front, the H is minus H on the middle, and the plus K is on the end. Okay? So the HK is still a vertex here in absolute value, and everything else behaves the same way. We're going to follow the same pattern of going right one and up one, and left one and up one. And we're just going to make it a V shape, more of a sharper thing. Okay, so it should be very similar. Let's go ahead and do maybe a couple of these. Looking at number 11, we're going to do the opposite of this, just like before, and keep this one the same. So our new vertex, instead of being at 0, 0, it's at 5, negative 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, right about there. Okay? And there's no stretch, so I'm just going to go right one, up one, and left one, up one from my vertex. Just make it a nice sharp line here. It should kind of go through the middle of these boxes and just continue up in that angle each time. Okay? Let's take a look at number 13, if we have a stretch involved. Figuring out the HK still, so we're going to do negative 4, negative 2. This happens to still be our vertex. 1, 2, 3, 4, 1, 2. So it's shifted left and down. Now this time, again, a normal pattern is right one, up one, left one, up one. That's just because those are the numbers that we get in a plain, regular, absolute value of x graph. We need to multiply it by our stretch this time. So now we're going to go over right one and up 3. So again, it should behave the same as a parabola, as in a bigger number in front makes it very steep and skinny. Okay? So again, make sure you're drawing these absolute value ones like very sharp lines versus the parabolas are curved lines. If it's a negative stretch, remember that means we're going to change our direction. Instead of going up, we're going to go down. Okay, so you can continue filling out these ones, and I'm going to jump to square root. Alright, square root, basic one, the most basic one is y equals the square root of x. And with the shape that that's happening in, let's pick some points for a table here. If I pick negative 1, 0, and 1 again, negative 1, I cannot take the square root of negative 1, so that isn't super helpful. Square root of 0 is 0, square root of 1 is 1. We want to have 3 points here, so if I pick the next number I can square root after 1 would be a 4. And that's going to be easier to know than square rooting a 2 or a 3 in our table. Okay, so these are going to be kind of the numbers we're going to look for this time. So I have the point 0, 0, I have the point 1, 1 is approximately here, and the point 4, 2 is approximately like that. Square root looks kind of like a ray, a curved ray that just goes on forever in the one direction. Okay? In square root graphs, the HK is the starting point, is what we'll call it. It's not necessarily called the vertex anymore, we'll just call it the starting point. But it still can be stretched and shifted around like the other graphs. So we're going to still start by plotting the HK. We can plot 2 other points to create a square root function that follow a certain pattern. From HK, we can go right one, up one, and we're getting that from this point right here. Right? I would go right one and up one from the vertex. Then I'm going to go right 4 and up 2 because of this set of points right here. Okay? Then we'll connect them into this curved shape. And we'll do the same thing if there's a stretch factor, we'll multiply by. Okay? Taking a look at number 17, figuring out the HK first. 3 and then negative 5. So we're going to plot that first. 1, 2, 3, down 5. 1, 2, 3, 4, 5. So our square root graph, instead of starting at the origin at 0, 0, it's moved to the right 3 and it's moved down 5. Right? So that's the starting point. Everything else is going to be the same. It's like if I were to take all the points that were originally there and just move them down right 3 and down 5. So our little pattern for this one's going to be right 1 and up 1, right 4 and up 2. So from from the HK, which is the starting point, right 1 up 1, call that there, and then right 4 from the HK, 1 2 3 4 1 2. It's important we're doing these numbers from that HK each time. So it's just going to curve out in that direction forever. Okay. There isn't anything happening on the left of that starting point, because if I were to plug in, let's say right here, like x is equal to 0 right here. If I were to plug that in the equation, we're going to get an error. Right? I can't take the square root of -3, so that's why there's no points happening on that left side of our graph. Okay. Looking at one more here, and then we'll look at one of the stretch factors. So our HK, -4, -7. So it went to the left 4 and down 7. 1, 2, 3, 4, 5, 6, 7, right there. Okay. Again, remembering our normal pattern, which we're getting from this. Whoa, what am I doing? Getting from the more basic square root function. If I just picked those points in the table, and that's where these numbers are coming from. Okay, so from my HK, right 1 up 1, this point, and right 4, 1, 2, 3, 4 up 2. We'll just continue that. It's just a curve. I'm just going to continue going outwards in that direction. Okay. Oops, wrong way. Let's look at one more where there's a stretch. Okay. If we look at number 22, we have a 2 in the front. That's how I know there's a stretch happening. Still going to find my HK first, so the opposite of that inner one, so -6, and keep the outer one the same. So we went left 6, 1, 2, 3, 4, 5, 6, and down 2. That's where we're starting from. And remember our normal directions, right 1, up 1, right 4, up 2. So we do kind of need to memorize those, but that's the only one that's different. We're just focusing on these 3 parent functions instead of all of them all over again. So we have a stretch this time, so we need to multiply the vertical distance by 2. Okay. Our graph is getting taller. That 2 is multiplying all of our y's, so they're getting bigger than they normally were. We're going to go right 1 and up 2 this time. Oops, right there. Right 4, 1, 2, 3, 4, and up 4, 1, 2, 3, 4. So it's much higher. It's increasing much more quickly when there's that stretch of a 2 in the front. Okay? Jumping back real quick to number 21, I just want to point out there's a stretch. It doesn't change the number that it goes up or down, but it does change the direction. So this stretch right here of negative is going to change all of these to go, or these 2 to be downward moving instead. Okay, so your graph is not actually going to look the same curved direction as it has been in the other square root functions. Okay? So make sure you're going back and doing the ones that we didn't do together, and ask questions. If you have any, this is review, so this is something that you did learn before. So this is all about making sure you understand it, because we're going to use this stuff later in the year in our next chapter.